For 6.1, we're looking at graphs of normal probability distribution. A normal distribution has a graph that's bell-shaped and curved, and that curve's called your normal curve. So the main thing you need to remember is it looks like that bell shape. The middle part has to be the highest part, and from the rest it goes down from there. So they have some information here about your normal curve. So with your bell-shaped curve, the highest point's going to be your mean. That's the main thing you have to remember. The highest point's going to be in the middle. Your mean is always in the middle. The rest of it then is everything under your curve is going to add up to 1. So the area under the curve is like probabilities. So when you add up all your probabilities, you should have 1. Same thing here. If you add up everything under your curve, you should have 1 for your total. Now here, for example 1, we have 2 normal curves. We've got A and B. The question is, do these distributions have the same mean? If so, what is it? So they do have the same mean because if you look, they're both there in the middle at 6. So both A and B are in the middle to have a mean of 6. Then it says one of the curves corresponds to a normal distribution with your sigma equal to 3 and the other one to sigma equals 1. Which curve has which sigma? So if you have a sigma of 3, that means you're going to be more spread out because every step away from it is 3 for your sigma. So it's 3 parts away from the mean. And then for your other one, when your sigma is 1, that's going to be a skinnier graph because you're just moving 1 to the right and you're going to have 1 standard deviation away. If you move one other one to the right, now you're 2 standard deviations. So you have 2 standard deviations away with 2 steps. Whereas for the other one, if you have 3 for your sigma, you're looking at 1 standard deviation then is 3, whereas 2 standard deviations away is 6. So it's more spread out. The bigger your sigma, the more spread out then your curve is going to be. So that means then our A has a sigma of 1 or standard deviation of 1. Our B has a sigma of 3. Now we have what we call the empirical rule. So if you look at the pretty picture there, that kind of explains the empirical rule with pictures. So if you have this bell-shaped curve, approximately 68% of the data fall within 1 standard deviation on each side of the mean. So if I look at my picture here, if you look at your mean, it's in the middle. So if we are 1 standard deviation away, that's 1 this way, 1 this way. So you're looking at 34% to the left, 34% to the right. So total then between those two is 68%. For the second one here, you're looking at 95%. So if you go 2 steps away both ways, the total of all those percents is going to be 95%. Now if you go almost those 3 standard deviations, you're going to get 99.7%. This is not 100% of your data because there is still a small chance of being outside 3 standard deviations either way. But most of your data is going to fall between 3 standard deviations to the left, 3 standard deviations to the right. So it's 99.7. So you can't say it's 100%. It has to be 99.7 between your 2 standard deviations of 3 steps away, 3 steps away. Now we're going to use this picture here for example 2. So if you need to look at that picture, we'll help you go through example 2. So it says, the playing life of a sunshine radio is normally distributed with a mean of 600 hours and a standard deviation of 100 hours. What's the probability that a radio selected at random will last from 600 to 700 hours? Remember, probability is going to be between 0 and 1. So when we find a probability, I don't want the percent because it will say percent if they want percent. You have to turn your percent into a decimal to have probability. So in this information here, if I make that little curve, it's okay, your pictures don't have to be perfect. So your middle is your mean. So that middle line there for us is our mean is 600. Now, they're telling us we have a standard deviation of 100. So that means one standard deviation to the right is going to be then 700. One standard deviation to the left would be 500. Now, if you look back to that picture there and you move one standard deviation to the right, this is going to be then our 34%. If I go one standard deviation to the left, it's also 34%. Now, if we go 2 in either direction, you're looking at an additional 13.5 on both sides, and so forth. So it looks just like that picture there. Now, they want to know what's the probability that a radio selected at random will last from 600 to 700 hours. So you have to find the percent that matches up with 6 to 700. So if we look at our picture, 6 to 700 is that 34%. So that means we would have then 34%, but that's not probability. That's your percent. So our probability then would be 0.34. So yes, it is a 34% chance of it happening for that selected radio to last between 6 to 700 hours. Now I want you to read through this one and pause the video, and you do the same thing. So you're going to draw the picture, see how it matches up with your percents. So you should have an answer to this one now. So it says the yearly wheat yield per acre on a particular farm is normally distributed with a mean of 35 bushels and a standard deviation of 8 bushels. What is the probability that the yield will be between 19 and 35 bushels per acre? So draw the picture, because some of us need that picture. I know some of you don't. Some of us do need to see that curve here. It says our mean is 35, so down the center, we've got 35. Now, they tell you your standard deviation is 8. So that means if you move one step to the right, we have to do 35 plus 8. So if I move one step to the right, then I would have 43. Now remember, one step to the right is our 34%. Now if I move one step to the left, I have to take 35 minus 8, and that gives me a 27. So now we're at 34% to the left of the mean. Now they want to know the probability that the yield is between 19 and 35. So if I want 19, I've got to go down one more so I can see where we're at. So if I'm at 27 and I want to go one more spot to the left, I have to subtract 8 again. Every time you move a spot to the left, you are subtracting 8 every time. That's your standard deviation. So I've got 19. Now, look at the picture. The picture tells us one more spot to the left then is 13.5. So we have to move left one step, move left another step. So now if we want 19 to 35, we have to take 13.5 plus 34. So when I add those two together, we're going to get 47.5%. Now it says what's the probability, so we have to turn that into a decimal. So 0.475. When you go through your web assign, some of the problems will have the picture there for you with your percents. Some of them will not. So you have to think where your percents fall. It might help you to draw the picture every time, or at least think how many steps you have to go and what the percents are that match up with those steps.